So I'm going to cover 6.1 and 6.2 today, and we're basically going to do homework. We're going to practice today 6.1 and 6.2, and then also on Tuesday 6.1 and 6.2, since we don't have classes on Monday. Okay. But the reality is I'm going to go through some just basic rules for 6.1 in terms of antidifferentiation in indefinite integrals. And these are the basic rules, and then we'll get into some more complicated stuff for 6.2. This is just a general review. we're not actually going to do any problems for 6.1. Okay, this is on page 120. This box is on page 120 in your workbook if you want to just screenshot from there. But I'm just going to go through all the little rules just as a reminder or refresher, and then we'll just start using them in 6.2. So the power rule, of course, remember that it's called antidifferentiation because integration and differentiation are inverse kind of operations. So when we're working the power rule for integration, we kind of work it backwards. With derivatives, the powers always go down. Well, with antiderivatives or integrals, the powers go up by 1. So, of course, this is the power rule. You add 1 to the power, and then you have to divide it by that power, whatever that new power is. Or you could multiply it by 1 over n plus 1, right? These are, I'm going to fly through these now, okay? So the constant rule, if we have a constant, the integral of a constant, then it's just the constant times x. Don't forget about the c, okay? Because there's always an additional constant that you have to tack on when you are finding an integral. And that has to do with shifting versus on a graph. That we talked about it when we were doing chapter 5, that it could be a vertical shift. That kind of represents that. Eventually, in 6.1, you have some problems where you will find the constant. You have to be given some information in order to do that. So if you have a constant, then it's just going to be the constant times x, assuming that we're integrating with respect to x. This can be different too, right? Then we have scalar multiplication. So if you have a scalar, a constant being multiplied by some function, that constant can just come out in front of the integral and we can ignore it, okay? Constants can be factored out, but you can't throw a variable out there. This is only for constants, okay? Sum rule, so if I'm taking the integration of a sum, you can treat them as the sum of 2 integrals. Exponential rule, we've got the integral of e to the x is still e to the x. And then again, we're working these backwards. A to the x is the same as a to the x over a natural log of a. And then you have all your trig rules. And I didn't put them in. Or maybe I did. Oh yeah, no, because I want to go through them with you. So actually you fill those in. Let's do that. Fill those ones in there, and let's see what you end up with. All right, who wants the easy one? All right, Ava, what do you got for the integral of cosine? Just straight up sine x? Sure you don't want to add anything? Plus c. Don't forget your plus c. Okay, so all you guys forgot your plus c. That's really easy to forget, but you gotta always have it. You gotta have your plus, you gotta have that constant, okay? All right, the next easiest one. Who wants it? None of you want more of a challenge?
I'm not sure about my easy ones apparently. So.
Oh, well, just because you left off the plus c, it's okay.
Can I guess?
All right, just go ahead, sine of x. Okay.
Oh, that's not the one, okay.
Yeah, we're going across. Is that right? Is it negative cosine or is it cosine? Negative.
Yay!
Okay. And if you aren't sure, what can you do to be confident in it? Take the derivative of it, right? Take the derivative of it. All right. The next one should be easy. Yeah, tangent x plus c All right. Who wants the next one? Cosecant squared. No, you can't go again. Grant, what do you got?
Oh boy.
No.
Is it cosine x plus c?
What do you think? Do you guys think he's right?
What do you say?
What do you?
Cosine x plus c
I think it's negative.
is a negative.
Oh my god.
All right. All right. So now these get a little trickier, right? Because you have to remember your trig functions. Who wants the secant tangent?
Secant x plus c.
Say again.
Secant x plus c.
Secant x plus c. There's only one left. All right, Soph, what do you got?
Negative cosecant x plus c.
No negative cosecant x plus c. Okay. Now, if you didn't remember all those, I understand. Hopefully you remembered the first few. Okay. The last ones always get a little, like, you have to really jog your memory on some of that stuff. But those will come into play. All right, let's get into 6.2 because that's
it.
that's all I'm doing for 6.1. Okay, so 6.1 practice, it's really review of this. But you can't do 6.2 without knowing how to do 6.1, but I just didn't want to spend a lot of time